This video is about ray diagrams for concave lenses. So if we think about ray diagrams, light ray diagrams are used to explain how mirrors and lenses can work. Now, if you look in your notes, there's lots of different information about this. First thing I want to think about is what we even care about with lenses and mirrors. Now, we're trying to predict image information. And what we mean by image is, what do you see in the mirror, or what do you see through the lens? So one thing we care about is where the image is. And this is about the image distance. Okay, so where it is. We'll talk a lot more about that in a little bit, because that one doesn't really make a lot of sense right now. Now, image size. When I look into a mirror, do I see myself as bigger than I really appear? Or do I see myself as smaller? Image orientation is talking about, is the image upright or is it upside down? And inverted means upside down. Is the image virtual or is it real? And that really we're going to talk about in connection with image distance in addition to orientation. And we'll talk about that in a little bit. So the first thing we're going to do is just look. Oops, where is it? Look and see. Why isn't my simulation showing? We want to look and see what these even look like. Sim bucket, there we go. So we want to change it to mirror, and I'm going to turn all the rays off. Okay, so here if you look, that candle on the left is our object. Now this you can move around. Now the other candle you see is the image. So like this image is an example of a smaller image. If I turn that up, you can still see that that second candle is smaller than the original. I can also see that it's inverted, upside down. And the real virtual we'll get to later. So we use ray diagrams to predict what that image is going to look like. And we do it through drawing rays of light and looking to see where the rays of light intersect. So we always draw the same rays of light. And we always, there are three options and we need to choose two. So one option is that it goes completely flat, parallel straight to the mirror, and then reflects down through the focal point. Second option is the opposite, that it goes through the focal point, then parallel, flat, straight. So that one. Third option is that it goes through the center of the mirror and then reflects at the exact same angle, because we know about the law of reflection. And so when I turn all three of them on, it's a little overwhelming, but we want to see where all three intersect. Notice we're looking not at the beginning rays, but at the ending rays, the reflecting ones. You don't need to always draw all three, though. You can just draw two. These are the two I usually draw, but you can choose. So let's look in your notes and just do one example there. So we're going to kind of scroll and bounce around. So concave mirror examples. You should go and watch this link to do all these examples, because we are just going to do one here together. So the first ray that we draw is straight. Oops. Helps to have a ruler here. Straight through the focal point. Next one is opposite of that, through the focal point. And then parallel or straight. Now, already with two, we can see where they're intersecting. But just to be on the safe side, we can draw a third one. And they should all intersect at the same location. When we draw in the image, we always start at the center and point to the intersection. Now, in describing the image, we can describe this as an inverted image, just because it's upside down. We can describe it as smaller, because this arrow is smaller than the original object. So when I look in this mirror, I'll see my face being smaller than it actually is in real life. And lastly, I can describe it as real. Now we can get into this one a little bit, what real and virtual are. The real side of a mirror is in front of the mirror. This is all where the real light is, because light for a mirror is coming in and then bouncing out. Okay, it doesn't go through to the other side of the mirror. However, sometimes we have images that are virtual, and this means that a real image is not formed in front of the mirror, and we have to go to the back side of the mirror. We do that when there is no intersection of light and when we need to trace the reflected rays back. So let's see an example of what that looks like. Here, this is all real images, real, real, real. Now it's bigger, but still real, real, real. As I flip here and get really close to the mirror, I have this virtual image. It's virtual because it's on the back side of the mirror, and it's virtual because it's not a real intersection of light. Now watch the video attached to your notes to see how you draw these virtual images.